Welcome. Let's take a look at finding the antiderivative of functions that involve the power rule. In this case, we have the antiderivative of 3x squared minus 2x to the first plus 1 dx. Now, let's remember that the derivative using the power rule of x to the n is equal to n times x to the n minus 1. Since we are finding the antiderivative, we will be starting with the x to the n minus 1. So the antiderivative of x to the n minus 1 dx, recall that in this derivative process we had to subtract 1 from the exponent. So to reverse that process, notice that we're going to have to add 1 to the existing exponent. So n minus 1 is my existing exponent, and now I need to add 1 to find the antiderivative. Now, recall that when you use the power rule, you do end up with this coefficient in front. So we need to accommodate for that. So we need to divide by that new exponent. So really quick, let's suppose that my function was 1 over n minus 1 plus 1 times x to the n minus 1 plus 1 power plus c. So we're going to assume that that's our function, and what we should end up with when we find the derivative should end up being that x to the n minus 1. So let's go ahead and find our derivative here. So f prime of x is equal to, now our original coefficient is n minus 1 plus 1. Now we're using the power rule. And so when we use the power rule, we will bring our exponent and turn it into a multiplier. So we'll have n minus 1 plus 1 times x to the, and now we're going to subtract 1 from this exponent. And when I subtract 1 from this exponent, this plus 1 will go away, and I'll be left with n minus 1 as my new exponent. And then when I take the derivative of plus c, I end up with 0. Now notice that we have 1 over n minus 1 plus 1 times n minus 1 plus 1. So those are the same value. They're reciprocals, and so when you multiply them, they multiply to equal 1. So our derivative does in fact end up being x to the n minus 1. So now that we are fairly convinced that this process works, let's see how it applies when we find an antiderivative. So taking advantage of the linearity of the integral, we have the antiderivative of 3x squared dx minus the antiderivative of 2x dx plus the antiderivative of 1 dx. Now, using the power rule here, for our first antiderivative, let's go ahead and notice that we can bring our constant factors 3 and 2, or coefficients, in front of the integral. So we'll have 3 times x squared dx minus 2 times x dx plus the antiderivative of 1 dx. So applying the inverse or the opposite of the power rule, we'll have 3 times. Now, my x squared, that exponent, I need to add 1 to it. And then I need to multiply by whatever that new exponent is. So 1 over 2 plus 1. Minus 2 times, and we're finding the antiderivative here. So my exponent currently is 1. I need to add 1 to it. And then I need to multiply by 1 over that new exponent. Plus, now this last term, we should recognize as the derivative of x. However, you may not recognize it as such. What I can do is, instead of thinking of that as 1, I can think of it as x to the 0 power. And when I apply this power rule process integration, we'll have x to the 0 plus 1 power, and then multiply by 1 over that power. And then we'll have plus a constant. Now notice here that this denominator is 3, and we're multiplying by 3, so that will become a 1. Notice that this denominator is a 2, and we're multiplying by 2, so that will become a 1. And then this fraction is a 1. So our antiderivative is 1 times x cubed, or just x cubed, minus x to the 1 plus 1, so that's x squared, plus x to the 0 plus 1, or x to the first power, plus c. Now, we didn't necessarily need to use this rule. We could have noticed that 3x squared is the derivative of x cubed. We could have just noticed that. Minus, we could have noticed that 2x to the first power is simply the derivative of x squared, plus, and then we could have noticed that 1 is the derivative of x. So we could have been observant and arrived at x cubed minus x squared plus x plus c as our antiderivative, or we could have relied on what we know about the power rule. Let's look at another example. In this case, we've got a product of 2x plus 3 and x minus 2, and we want to find the antiderivative. Now, I do want to caution you that while the integral is linear, we cannot, and we can separate addition and subtraction. We cannot separate multiplication. In other words, this integral, this antiderivative, is not equal to the product of the antiderivatives. Much like you had to learn the product rule for derivatives, there is an alternative process for dealing with products, but fortunately in this case we don't have to. We actually have the tools we need to be able to find this antiderivative. And what we need to do is to simply multiply those two factors together and then integrate. So we'll have the antiderivative of, let's see, we'll have 2x squared minus 4x plus 3x minus 6 dx. And we can go ahead and combine the minus 4x and the plus 3x. So we'd have the antiderivative of 2x squared minus x minus 6 dx. And now we can go ahead and work on finding our antiderivative. Using linearity, we can break this apart at addition and subtraction. We have subtraction here, so we can break this into 3 separate integrals. And we can pull this constant multiple, this coefficient of 2, in front of our integral symbol. So we would have 2 times the integral of x squared dx minus the integral of x dx minus, and now instead of writing that as the integral of 6 dx, we're going to write that as 6 times the integral of 1 dx, where 6 times 1 is certainly equal to 6. So now we're ready to find our antiderivative. So we have 2 times, now the antiderivative of x squared, that's going to be x to the 2 plus 1, and then we multiply by 1 over 2 plus 1, minus, we'll have x to the current exponent is 1, so we need to add 1, so x to the 1 plus 1 over times 1 over 1 plus 1, minus 6 times, and then the antiderivative, as we saw, of 1 is simply x, and then plus our constant. Now, this denominator here is a 3, so we'll have 2/3 times x, and that exponent is a 3, so 2/3 x cubed, minus this denominator is a 2, so we have 1/2 x, and my new exponent there is a 2, minus 6x plus c. And there's our antiderivative. Let's go ahead and look at one more example. Again, using the linearity of the antiderivative or the integral, we can break our integrand up at addition and subtraction. So we will go ahead and do that. And then we can pull out any coefficients, so this -10 and this 3. So what we'll end up with is the antiderivative of x cubed dx minus 10 times the antiderivative of x dx plus 3 times the antiderivative of 1 dx. Now, using what we know about the power rule, we will need to add 1 to the exponent for x cubed. So we will have x to the 3 plus 1 power, and then we multiply by 1 over 3 plus 1, minus 10 times, now x's current exponent is 1, and we add 1 to it, so we have 1 plus 1. So 1 over 1 plus 1, or 2, plus 3 times, and we should know now that the antiderivative of 1 is x, plus our constant of integration. Now, this denominator is a 4, so we have 1/4 x, and that new exponent is 4, minus, now this new denominator is 2, and 2 and 10 can simplify to 5, so we'll have minus 5x squared plus 3x plus c. I hope you find this helpful.